This is Gail Kovac for Gresham Barlow School District. This is summer school, high school credit recovery, Algebra 1B, and learning target number 4. I can graph an absolute value function, y equals a, absolute value of x minus h plus k. So an absolute value function is asking how far values are away from 0 on the number line. So obviously, with an input of 0, we get an output of 0. 0 is 0 steps away from the number line. For a value of 1, 1 is 1 step away from the number line, 2 is 2 steps away, 3 is 3 steps away, etc. So if we look at all the values in between those whole numbers, your basic absolute value function goes like this. But what about the negative numbers? Negative 1 is 1 step away from 0. It's not negative 1 steps away, it's a distance. You wouldn't say you walked negative 6 miles to the store. That's just not how we talk about distances. Distances are positive. So although negative 1 is in the other direction, it's still 1 step away from 0. Negative 2 is 2 steps away in the other direction. Negative 3 is 3 steps away, etc. So our base absolute value function starts to look just like this. Now, once you start throwing more things in, like this internal adjustment of negative 2 and this external adjustment of plus 3, that's basically going to just take this base level absolute value function and move it around and adjust it a little bit. So we have an a in front. Your a is your multiplier, which will determine if the absolute value function opens upwards like this, if it's positive, or if it opens downwards instead, if it's negative. It would take all those values and multiply them by negative 1 instead. If your a value happens to be larger than 1, it's going to make this a skinnier function. If it is smaller than 1 but greater than 0, so if it's a decimal less than 1, it's going to widen and flatten it out a little bit. In these problems, a will always be equal to 1. It'll either be positive and you don't see it, or it'll be a negative 1 just with the negative component shown. So your a value, it's either going to look upwards just like this, or it will be going downwards instead for that negative right there. The point of the turnaround right here for your 0, 0 is found by h, comma, k. That is h, comma, k. That's kind of like your starting point, your home base for the function. That's where I would start to draw it. Now notice here that it's x minus h. So it wouldn't start at negative 2, 3. It's going to start at 2, 3. This part is already negative. That's by design. If it were to start at negative 2, then this would be minus negative 2 instead. So in this case, I just drew very lightly in this yellow color what the function, the regular function would look like. So now let's actually draw this one right here in purple. So this one is going to face upwards just like it did, because it's got an invisible positive 1 multiplier in the front. And my hk, that turnaround point, is going to be 2, 3. So instead of starting the function here at 0, 0, I'm going to scooch it over 2 and move it up 3. So it's going to start here instead. You're going to notice some parallel lines happening here. 1, 2, 3. And 1, 2, 3. You're basically going perfectly diagonal, although that was not so perfect. Perfectly diagonal in either direction here. Let's see if I can do a better job. I think I can. This one, this one, this one. There, that's much better. And it'll continue on up forever. So that only adjusted the h and the k here, only adjusted where that starting point was. It went over and went over 2 and up 3 instead. So now let's try this one. Let's do a different color for this one. I'll start with that basic function. Remember, the regular absolute value of x, we call it a parent function, starts like this, because from the parents is where all the kids come from, right? So you could call this yellow one the parent function, the base level function, and then all the different kids that you can get with all the different variations, right? It's a little silly. Mathematicians are silly. All right, so in this case, we got a couple things going on. We have our point where it starts at 4, -2. That's 4, -2. So instead of starting the point here at 0, 0, I'm going to start it at 4, -2. That's where it's going to start. Now, normally, if that were it, if this were a positive in front, then I would just go up and up like this. But I've got a negative in front. That's going to make it point downwards instead. So instead of going up like this, now I'm going to go down like that instead, perfectly diagonal across each of these unit little quadrants here. And then this one down instead of up. Hey, that was pretty good. Just like this. So this moved that starting point over here, +4 and -2. That's +4 right there, and -2. And it flipped it around, making it go upside down instead. Those are the main things that you're going to have to watch out for these functions is where is it going to start? And just remember it goes perfectly diagonal, either like of the letter V going upwards or a letter V going downwards, depending on if that A term in front is an invisible positive one or if it's a negative one.